जी रेहान, इट्स 2 PM। आप अपना वीडियो पे आप आ जाएं। जी रेहान, आपको मेरी आवाज आ रही है?
यस। जी सर, क्लियर।
आप जरा अनशेयर करेंगे स्क्रीन थोड़ी देर के लिए।
जी।
जो प्रिंट ले आना साथियों। बस ये फॉर्मली विद इन 2-3 मिनट्स हम स्टार्ट करते हैं। People start coming in right after 2 PM. So I'm just giving them 2-3 minutes so that I don't have to repeat the announcement again and again. I'm just waiting for all the people to join, and then inshallah I will start you. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum. Good morning and good afternoon from Pakistan Society of Civil Engineers based in Lahore, Pakistan. A very warm welcome to all the participants and to those who have joined us on Facebook. This is technical lecture number 83. Those who have joined us first time, it is for their information that PSCE holds one technical lecture every month, and by attending this lecture, you can earn half CPT point, which is recognized by Pakistan Engineering Council. Now, before I introduce the speaker and the topic, it's my responsibility to read out the rules of this webinar. The registered participants for CPT points must appear live on webcam. However, for the ladies, there is an exception. If they wish, they can cover their face while appearing live on the webcam. During the lecture, microphone of all the participants except that of the speaker shall remain in the mute position. There will be a 20 minutes question answer session at the end of the lecture. And let me remind you, there will be no live questions asking through the microphone, and this rule will be strictly implemented. You can type your questions in the chat box. Inshallah, I will read those questions, and if there and the speaker will answer those questions. In case if there is any question during the lecture which I feel should be asked at that time, I will ask that question, and inshallah, the speaker will answer that question. Same facility is available for our participants on Facebook. Now, today's topic is building resilience through Forsenic insights, a structural engineering perspective. Rehan Wyne did his undergraduate degree in civil engineering from UET Lahore with honors. He is also a graduate of MS Structural Engineering from the University of California, San Diego, USA. He is a licensed professional engineer in the state of California, USA, and Pakistan. He is a lead accredited professional and project management professional. He has been a young professional member of Earthquake Engineering Research Institute, EERI, and Southern California Structural Engineers Association. He has worked in Los Angeles as a structural engineer, where he contributed to a wide spectrum of multi-million-dollar projects in the Los Angeles County. His work encompasses the structural design of multi-story buildings in concrete and steel, both for new and existing structures. The projects include commercial and educational buildings, hospitals, and the Los Angeles airport. He was a part of the structural design team that led the billion-dollar upgradation work of the Los Angeles International Airport, a project aligned with the requirements of 2028 Olympics. Now, this was a very brief introduction of young engineer Rehan Wyne. Now, I give the floor to engineer Wyne, and please, Rehan, start your lecture. Thank you.
Thank you, Mr. Tahir. Let me share my screen first. Okay. Thank you, Mr. Tahir, for the kind introduction, and I welcome you all to today's talk. Good afternoon, everyone, and thanks for joining. So, a year ago, when I planned this lecture, when PSCE approached me to give a lecture on this subject, I initially thought of talking about the structural resilience and the aspects of forensic analysis for the structural design. But over the stretch of the last 1 year, what I realized that instead of diving right into structural design and resilience, I think would be more beneficial if we zoom out a bit and first try to understand what our development frameworks need to be for the infrastructure. Why we design our infrastructures in a certain way, what should be the vision, the policy frameworks. I think that is even more important than just talking about the structural engineering aspects of it. So we will first start from the overview of the infrastructure development frameworks, and then we will dive into the resilience and structural engineering aspects. So when we usually as engineers talk about infrastructure, what we usually imagine are bridges, highways, power plants, transmission lines, or digital networks. But we also need to understand that these infrastructure projects are essentially supporting are not just like the physical assets that support the economy of a country, but they are essentially a communication channel between different communities. And they are an infrastructure is basically tells how well an economy or a country can adapt to the changing times, to the requirements of the changing times. So the question today should not be just focus on how we build more infrastructure or how we build more infrastructure projects, but rather the question should be how we build, how we finance these projects, what should be our policy frameworks, and how we can ensure that we are utilizing our existing infrastructure to its true potential. So this is how I have phrased the today's talk. And if I move forward, so the today's outline will basically first talk about what we mean by infrastructure, what's the purpose of it, what it's designed to serve the communities and the frames it should be serving, and the modern development frameworks that have been adopted by different nations and different regions in the world, and how there are lessons to be learned for us. Now, in lieu of this, to support the infrastructure development and the new events that are happening, this is where resilient infrastructure comes into play, where we need to ensure that an infrastructure uh, 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 can support that requirements of the changing world. So, if I start I think I want to kick off my presentation from an image from the recent 2025 floods, the unfortunate event that we just experienced in Pakistan. I think this event is a classic example of how natural hazards have been turned into disaster due to poor planning of the infrastructure development, due to a lack of concept of resilience and preparedness. And what has essentially happened is that now we have millions of people who have been affected by the floods in one or another way. There has been a wide scale of destruction that perhaps all of us have already seen, so it doesn't make sense to go and give all the numbers at what has happened. But what we need to realize is that this is not just a loss, a temporary loss of an economic loss, and it cannot be something that we talk for a few weeks. And after within few weeks or months, this event is just gone, and then we are just waiting for the next big one. Is when the next big one is going to hit us. Instead, the focus should be to devise the right policies and frameworks for the infrastructure development, for disaster risk management, and ensuring that whenever the next hazard comes in, we are in a much better position to cater to these hazards. Now, unfortunately, what we see is that a lot of the talk after the recent flood has been focused around few of the topics. It has been focused around a real estate project that happened on a bank of Arabi. I'm not saying what was done right or wrong, but I think what needs to understand is that we cannot just eliminate what has happened in the larger scheme of things. And the talk should the conversation that needs to happen in the technical sphere at least needs to realize that there is a very large management and policy framework breakdown that's happening, and it needs to be catered to stop such events from happening in the future. Now, in a very sharp contrast, very unfortunately, in a very sharp contrast, that what we are seeing in Pakistan, that we are actually struggling to define the very basic prerequisites of what a good development model needs to be. In a very sharp contrast, the developed world or the emerging economies who have incorporated some basic good principles of development are not only fulfilling the basic needs of their individuals around security or communications, but they are building the development models are centered around creating communities that are closely tied, have a very good form of communication and connectivity, and are in line with the nature. So it's not just meeting the basic needs, but creating an environment, ensuring that we have a certain kind of environment around our cities and metros, which can create productive and innovative, can give out productive and innovative solutions. Now, when in order to get to there, what we need is that our infrastructure development policies are framed in the right manner. And our structural engineering, civil, and in the broader spectrum, I would say the civil engineering is able to provide that technical base for that transition to happen. So now we know I think we understand that where we stand as of now, and we kind of know where we want to be, but we first have to understand the challenges that we have in our hand. And like I mentioned before, the first challenge is that there is a lack of good infrastructure development framework. and that is something that needs to come from the top. It doesn't come from the bottom up. It's a top to bottom approach. It needs to come from the policies, from the folks who are creating those policies, and then it needs to be implemented by the regulatory by the organizations. And then the consultants or the designers come at actually they come into the picture at the third step. So if we look into, for example, I was reading a report by the IMF, and IMF says that that report, economic report, said that the budgetary spending that developing nations are doing in terms of infrastructure development, they say 30 to 40% of that spending is being wasted because of poor planning, inefficiencies, and corruption. So it's not just the corruption is at the play, it's actually incompetence and lack of will that is, I would say, is even a bigger element into the picture. So when we talk about infrastructure, the first thing that needs to be there is a development framework that is able to support our future developments and our aspirations and goals as a nation. Now, if we want to achieve that, the second challenge is going to be financing. How we are going to finance our infrastructure assets, how we will improve what we have to a better infrastructure asset class. Now, in terms of financing, what a lot of nations have started to look into it, that instead of financing these infrastructure projects right from the public money, they are looking into alternate financial classes. And we will talk about this in detail. For example, public-private partnership is one of the models, or bringing in the funds from the asset management companies and giving them and basically opening the infrastructure financing to the private sector is one way to fill that financing gap, basically. And the third challenge that we have in the infrastructure is that our infrastructure needs to provide that base for the digital and AI transformation. So whatever is happening in the digital upgradations or artificial intelligence, the infrastructure that we provide in form of telecommunication towers, in form of data centers, or high-speed fiber optics, uh, everything in the digital sphere is heavily dependent upon the reliability of those frames that we will need to have. Another thing is the geopolitical instability and supply chain disruptions. So what we saw recently in the past few years after the COVID-19, we saw that how certain events or events or pandemic can actually limit the communication channels between different regions, or even within a certain region. So now, in case of that, you are more dependent on yourself. We need to have our infrastructure right in the position so that we can create that value out of our country, and we are less reliant on the sources that are overseas. Now, another challenge that infrastructure development faces is the explosion that's happening in terms of the population growth and the trends. We see a rapid urbanization where few of our metro cities, for example, I would say Lahore or Islamabad recently, are experiencing rapid growth. And what we see is that there is a lot of migration that's happening from towns, smaller towns or villages towards these main metro cities. So what the policy makers or the regulatory departments have to basically understand is that there is a population stress on few of the big metro cities, and they need to understand that the infrastructure of certain cities need to be able to cater to the needs of these population migration. And the last, not the least, that we talk about is the climate change. Of course, there is a climate change that's happening. We see more frequent events that are happening right now in forms of drastic rainfalls or earthquakes. So the infrastructure needs to be able to cater to the climate change. But I would like to stop at this point, and I would say that this is another unfortunate thing that's happening right now, that after the recent rainfall, the entire debate has been spun in a way that everyone is saying this is due to the climate change, or this is because of of something else. But what we need to understand that the first we need to be able to have good management systems and the right development frameworks before we come down to the climate change. The climate change would not be able to affect our infrastructure or real estate or our people to the same degree if we have the right frameworks and the management systems. So when we talk about infrastructure, we have to realize what we mean by the infrastructure. So broadly speaking, we can categorize our system into three elements. The first is economic infrastructure, and by economic infrastructure, it means those hard assets such as roads, highways, tunnels, barrages that are basically essential to supporting the economy of the structure of the nation. The second is the social infrastructure, such as hospitals, schools, or housing, or even the developed green portions or green spaces that we have that are essential for the well-being and human experience. And the last not the least is the digital infrastructure. So digital infrastructure is anything that is supporting the transformation in terms of data centers, fiber optics, or telecommunication tower. So when we talk about infrastructure, we need to understand that there are different elements and how those elements are play into the picture of the larger scheme of things. Now, transitioning to moving on to the next slide, what I want to show here is basically how the development frameworks have transitioned over centuries. So in the past, for example, this cartoon image that you see on your screen on the top left corner is showing Mohenjo-daro. These ancient cities are used to be developed in a way that they provide for the basic needs of their inhabitants. So whoever's living there, your basic facilities would be a basic level of road, your water utility lines, and your sanitary systems, and your basic levels of transport. But the modern cities or the big metros of today are not limited to providing the just catering to the basic needs of the citizens. But what they need to do is create an environment that fosters inclusivity, connectivity, and creates a productive environment where the culture is centered around productivity, what kind of thing you deliver, how quick we are able to deliver. Now, in order to deliver this kind of thing out of a metro city, what's needed is that the infrastructure development needs to be resilient to the natural hazards. It needs to be reliable against all the changes that will happen, and it needs to be sustainable. And sustainability here means that it needs to be harmony with the nature and needs to have those sustainable practices that can ensure that the metros or the metro cities or the infrastructure development that we do can last not just few decades but centuries. So what basically this shows you is how the infrastructure must transition and adapt to the changing economic, social, and environmental realities of the world. Um, so now when we dive into the modern infrastructure development, there is a huge debate around infrastructure 1.0 to 2.0. What that necessarily means is that infrastructure 1.0 basically means that that's your basic infrastructure that we comes into our mind in forms of roads, bridges, rails, ports, power plants, transmission lines. So these are like the basic backbone of your economy. And such infrastructure development was mostly funded by the government, by the federal government or the state governments would pitch in the money and these projects would get built, or they would be sourced by our debt that we source from the external sources. But now what we need is much more than this. We are essentially transforming our energy requirements from the traditional sources from coal and petroleum products to clean energy sources such as solar parks, smaller dams, I would say, and windmills, and this kind of like the clean energy sources. So for this to happen, we need more sources of finances. We cannot rely that the government alone can finance all these projects, or this can be sourced just of the public debt. So there is a transition that needs to happen in the infrastructure industry to able to support that initiatives for clean energy, sustainable development, and the digital transformation. And for that to happen, we need new finance models or new financing sources, or we need to actually be able to manage our finances in a much better way. So that is actually what the entire development framework should essentially mean. Now, since we talked about the transformation inside the infrastructure development, there is a very this is like a very hot topic and a rising debate within the huge investment fund companies is that they have started to see infrastructure as an asset class. Infrastructure is no more there just to provide the utilities, but a lot of the circles have now started to understand that since there is a huge demand in the infrastructure development, that we are transitioning from one form to another. Why don't the private money or the investment funds come in to support that transition? But for that money to come in or the investment to come in, what we basically need is a very good infrastructure asset management. We should be able to manage our assets. Infrastructure projects, for example, you will see bridge constructed in Lahore. I don't want to name the bridges, but some of the bridges or flyovers were constructed, and after 2 to 3 years, they have to be closed because of some minor defects that were not taken, minor defects that happened because we didn't account for certain design, or we build an infrastructure project and then we forget about it. There is no understanding that those projects need a regular maintenance for them to be operational and deliver the desired value to the economy and to the people. So if we are able to manage our existing infrastructure in a much better way, what would essentially happen is that we will draw the investment and money from different sources, because more of the investment sources would be interested to pitch in the money into those infrastructure projects, because they know that we are able to manage our projects in a better way, and they will essentially get their returns back from them. So infrastructure asset management is essentially looking at the infrastructure as an asset class, and being able to manage it right from the start till the disposal or decommissioning. Now, if if we talk about some of the modern development frameworks that we have around the globe, and I would like to give two examples. One is the European Green Deal, and another is the Vision 2030 of the Saudi Arabia, Kingdom of Saudi Arabia. Now, I'm sure a lot of us have already heard of Vision 2030, and we know there is a lot of transition that's happening. But what's essentially happening due to Vision 2030 is that Kingdom of Saudi Arabia is transitioning away from the reliance on petroleum and petroleum-based, the sale of petroleum and petroleum-based products, and they are now investing into green initiatives, or they are diversifying their basically portfolio, national portfolio, so that their economy is not just reliant on a certain asset class, but they have a spread of their portfolio where they can able to generate those income over extended period of time from various sources. Similar, but in a different way, I would say, is happening in the European Union, where the European Green Deal, through the European Green Deal, a lot of the nations are structuring their infrastructure management around certain aspects of the future. For example, so the key three elements that I think I can boil down to what those modern frameworks are looking into are sustainable development practices. They are starting to look into non-conventional financing methods of how they finance those models, and a concept of circular economy. Now, what sustainable development basically means is that we need to develop our projects without compromising our future. And what non-conventional financing methods, we will go into the detail, basically means, like I said before, the financing should not come just from the public money, but we need to open up our infrastructure and asset classes and invite the funds from different sources. And the third, but not the least, is the concept of circular economy. And what circular economy basically means, emphasizes on, is reducing the waste, using our resources to the full of their potential, and creating a long-term efficiency models. So these are like some of the just two of the cases that I gave for the development frameworks that we have. Now, uh, these development frameworks that the European deal created or the Kingdom of Saudi Arabia has created in form of Vision 2030 actually came from something that happened in 2015. I mean, they of course they have their own stuff going on, but in 2015, United Nations brought in experts from around the globe, and they gave out like a charter for 2030. What goals they identify certain goals that need to be taken into account by not just the policy makers, but by all the corporates and the engineering firms. And these were named as 2030 Sustainable Goals, SDGs. And this is something that you will find in across the border and a lot of corporates where they understand that what is going to happen in years to come. There is going to be less reliance on sources that are creating pollution or they are not sustainable due to certain aspects, and they would not be encouraged. Instead, the economies are now encouraging clean sources and sustainable practices. Now, all of these aspects cannot be handled by us engineers. Of course, a lot of this has to come from the policymakers. But for example, from an engineering perspective, one of these points, if you see the pointer number 9, talks about the sustainable infrastructure development practices. This is something that is totally relatable to us as an engineers or an architects. Now, we will go into detail and we see how how a sustainable development cannot happen without a resilient infrastructure. So we go into detail, but the idea here is to give you a perspective of why resilience is important, why we want to design, why we want to build in a certain way, and what we are basically trying to achieve here. Now, on the second pointer that I described for the modern development methods was looking into more infrastructure financing models. And so there could be several ways where we could finance our infrastructure transitions. One way is through the financing through the international organization or financing institutes such as World Bank or ADB, where they're lending out soft loans in forms of loans at the lower interest rate. But that is like one of the model. The second is that you bring in the money from the big investment firms such as Blackstone, BlackRock. These are just two big names, but there are like a lot of them. But for that to happen, like I mentioned before, infrastructure needs to be looked at as an asset class. It needs to be managed. It needs to be managed so that we can gain the maximum out of those potentials. Now, the second class or second way those infrastructure projects are being financed, for example, in case of Kingdom of Saudi Arabia, what they have is a PIF. PIF is Public Investment Fund. So what Saudi did is basically they are now taking out a fraction or I would say a huge portion of their earnings from the sales of petroleum and petroleum-led products. The money that they get out of those sales, they put it in their PIF fund. Now that PIF fund, they will use to create strategic infrastructure development projects. So they understand that we earned our money through the sale of petroleum. We have that cash. That cash would be used to fund those infrastructure projects that can bring in even more money, that can bring in even more, that can even foster even a better economy. So this is like one of the options of all. Everyone does not have the liberty like what Kingdom of Saudi Arabia has, but still that is one of the options where you take out basically a savings out of your national budget and you keep depositing and you understand that we will spend this budget on our development projects. Unfortunately, if you see in case of Pakistan, what has happened is our development spendings have been going down or remain stagnant for a long period of time. And that is, of course, because we have a huge debt and we have internal management challenges that we have not been able to address that have hammered the development spendings that we can have on our infrastructure. And the third and the last model is financing of the infrastructure comes from, for example, public-private partnerships. And what public-private partnerships means that the asset essentially belongs to the government, to the state, but they will allow the private sector to come in and have a share of the risk. They will share the risk with the government and they will run the infrastructure projects, for example, for the operations or management of the infrastructure. And this, we had our PPP examples, several examples in our Pakistan has done this experiments. At times, it did not produce the right results. But I think I believe if we have the right mentality and the right frames and we're able to negotiate with our private partners in the right way, we can surely be able to get good deals in these PPP models. And the last, not the least, is the concept of green bonds and climate bonds. So, for example, if in a country or nation wants to transition to a certain, for example, they want to build a solar park, what they would do is that they would advertise that they're building a solar park across the globe, and they would issue bonds in the market that anyone can basically purchase, and they are now a shareholder in that project, and they would get a return on equity for 5, 6, 7%, depending upon what the bond value is. So that is like another way of raising the finances for those infrastructure projects. Now, the last concept on the modern infrastructure development is the concept of circular economy. And this basically encompasses all the talk that we had till now. What circular economy basically means is that we need to design our wastage. It basically means that we do not start, that we take something from the nature or we take a certain resource, we use it and dump it. That basically means the economy needs to go in a full circle, where if I am taking something from the nature or in any form, I should be efficient in its utilization, in its production, distribution, the entire value chain. And then I should be able to manage my waste so that that waste can be used into certain other classes. And for in terms of if we talk about now narrow this down in terms of infrastructure or our construction, what that essentially means that when we're doing those infrastructure projects, our infrastructure projects need to have the durability that it can withstand the test of time. It needs to be adaptable to all the changes, and it needs to be resource efficient for the circular economy to work. So with this, we pretty much closed the first half of our talk, which covered why we need resilience. So the reason I talked about the entire infrastructure development, kind of like the very general overview, is to able to open this debate, that this debate needs to happen, not that we need to construct more, but the debate essentially needs to happen why we need to construct, why we need to construct, what needs to be the parameters that we need to take into account into our development frameworks, and how those will translate into a better connected world. We will able to preserve our resources, and we are essentially utilizing our resources to the full of their potential. Now, in order to get to that, what we need is a resilient infrastructure. For all those dreams or goals or vision to come true, we need to have a resilient infrastructure. What resilient infrastructure means by definition of it, it refers to systems and structures designed to withstand hazards with minimum downtime and be able to adapt to the changes. So what that basically means that in case, yes, we're going to have natural hazards, we will have circumstances that we did not maybe foresee to the full detail, but we need to have those systems and structures in place that can ensure that we have a minimum downtime. That it's not like if we are hit by certain hazard, everything goes down, and then we are now waiting, and we are not going to go back to our offices and think now what needs to be done, but we need to have those necessary planning and preparedness so that our downtime is reduced. We can come back to our operations in a span of few hours or few days, not months. Now, for example, if I talk now from a structural perspective, say we are designing an hospital facility that is that is envisioned to serve a community. When I'm designing the hospital, the design of the RCC structure or the concrete structure, steel frame, whatever type of construction it is, the essential thing is not that I designed my structure to the code base elements, just the frame structure, but I designed and I checked and ensured that all those utility lines are operational in case of an earthquake or any kind of hazard. So what that means is, for example, a facility, let's say a hospital, was hit by a very big earthquake. Okay, and let's assume, for example, the hospital did not collapse. It was able to withstand the earthquake. But all of the utility lines in form of water, sanitary, electricity, and communication lines, everything went down. And there is no planning how to bring that back within minutes or seconds or within few hours. If there is no planning for that, essentially your infrastructure is not resilient. Yes, your building from a structural perspective was resilient, but if you look into the entire perspective, that hospital cannot serve it cannot serve the purpose that it should have been designed to. So resilience needs to be looked at in from a broader perspective where there are multiple players that are there in the picture to ensure that that facility can actually deliver its desired goal. So now we I hope we kind of understand what resilience means for an infrastructure, but the question could be why resilience is important. It might sound self-evident that it's pretty clear, but just if we look into it, resilience is important to safeguard our communities, safeguard our economic stability and growth, and it's an efficient use of investment. I don't want if, for example, we spend millions or billions on developing an infrastructure, and if that infrastructure is not resilient in the case of an hazard, the entire purpose goes to the waste. So that's the entire goal of it, that the infrastructure needs to be able to serve its right purpose and should be able to deliver its value. And if we look into the last two clauses, for example, the fourth, I would say, maintain investor confidence. Now, this is similar to what I talked about before, that if we look our
Rehan,
infrastructure. Yes, sir.
Rehan,
Yes, sir.
uh, there is a question from a senior participant. He's from GC Go Khobar, Parvez Desai. He's asking what's the difference between sustainability and resilience? First one is more clear and understandable. So would you like to answer it now or you would like to answer it later?
Sure, I can answer it right now.
Better do it now. Yeah. Thank you.
Yeah, thanks. Okay, so what sustainability means in very easy way, what sustainability means that I'm using my resources to the true potential without compromising the nature or without compromising the future of the coming generations. That is what sustainability means in a very kind of like a chopped down way. What resilience means is that the system or the structure is able to withstand a shock or a damage and is able to come back to its original operations within few seconds or hours or a time. So there's a reduction of the time. So what essentially resilience would do is resilience will serve sustainability. Our goal is to have a sustainable infrastructure, means we want to develop infrastructure which is to the true of its potential. It delivers its desired goal without compromising the nature or the built environment. And in order to do that, we need a resilient infrastructure. That means we need resilient system. That means we need a system that is reliable against any kind of hazards. Uh, I hope I'm able to explain that. So coming back to the slide where we're talking about infrastructure resilience wise, it's important that I was talking that infrastructure needs to be looked at as an asset class. And when we are able to manage our infrastructure projects in a better way, what would essentially happen is that the investor money would come in. The investor money would not come in if there is a lack of confidence, or they can kind of sense that there is not a good management system in place for the infrastructure assets. And last is, of course, resilience is important when dealing with all the climate changes that are happening in the globe. Uh, so the word in resilience has you will find the word resilience being talked about. You will see that a lot of research papers. You will see that this term is used inside civil engineering departments. It's used in the architect, even in the architect departments. But you will also find that the concept of resilient infrastructure is not only discussed within the engineering or the architecture circles, but is also talked in the policy, in the circles where the policy formation comes into play. Now, UN developed two very good documents, I would say. They were not just like documents, they came out of long discussions and input from the experts. They developed some frameworks and principles of what a resilient infrastructure should have. So they are broadly named as like Sendai framework. And then the UNDRR principles are essentially maps out those frameworks. So I'm just giving out a reference. This slide basically just is a reference for anyone who's interested to read about why resilient infrastructure is important and how these frameworks were decided. And these documents have been there since I think 2015 and after 2015. Um, so when we talk about resilience, basically, going back, actually, I think I want to talk about what these documents briefly say. And there is like a word, there is like a line in this UNDRR principles document that I really like. And that line says that particular phrase actually says, disaster risk is not a natural happening, but it's largely a man-made problem. So that is like a shift. That should be a shift from the discussion where we see hazards as automatically being converted into disasters. Hazards do not convert into disasters unless we don't have the right mechanisms and the management systems in place. So that is what what these documents say, is that resilience needs to be looked into by the policymakers, by the regulatory departments, and by the consultants. So this needs to be a cohesive effort by all the sections of the society to ensure that whenever the next big one hits in the form of storms, floods, earthquake, or whatever, we are in a better position to handle those hazards, and those hazards do not automatically convert into disasters. Like so linking to what we just talked about, the risk that are induced in infrastructure projects, you would broadly, I mean, this of course doesn't cover everything, but broadly speaking, the risks that are infused in infrastructure projects, you would see they come from three bigger spheres. One is the development frameworks. If you don't have the right development vision, we don't have the right policies, right policy frameworks, that is automatically going to induce a risk that will be exposed later down the line. Then the second one that comes into picture is the regulation model. What regulation model means that the policymakers make a certain policy. Now it's the duty of the regulatory bodies to ensure that those policies are implemented by the private consultants. So there is a duty on behalf of the regulatory departments that they ensure that whatever was envisioned in the development frameworks is actually getting translated into the ground. And in the third steps comes into the technical model. Whatever the technicalities we go into in terms of creating better infrastructure, more safe built environment is comes into play into the third step. Of course, it's not like the least important, but we need to understand the entire picture of the development. Now, apart from the theory that we just talked, I want to share some few unfortunate examples of national disasters that we had in Pakistan in the last 20 years. Unfortunately we had a lot of them, but just talking about some of them, for example, we had the 2025 earth floods that we just recently have. There are different perspectives of why the hazard has translated into a disaster. My humble opinion is that it is a product of years of bad management systems and lack of preparedness. We had that there was an even the, if we look into the second example was the Liari building collapse that happened in Karachi. I think it was few months ago. There was a building that housed. There were some residential apartments on the higher floors. If I don't misquote, it was 7 to 10 story building. And that building was already flagged by the Sindh Department Control Authority. A lot of the residents had reported that they have heard cracking noises from the structure, but nothing was done. And the report started coming in 2023. And what ultimately happened is one day in 2025, I think it was May or June, if I'm not misquoting, the building just collapsed within few seconds, and hundreds of people were just like just died out of it. And another unfortunate event that happened just after this, the building was situated at a location where uh, the roads were very narrow. So when the building collapsed, the the for example, the emergency teams could not reach the site with all their equipments because the road was just too narrow for them. So they actually had to they had to use other means to get to the site where the disaster happened. So I believe this is another example of mismanagement and poor regulatory frameworks. The third example, for example, since I explained earlier that infrastructure is not just a physical hard asset. Infrastructure is also important to support, or we have to understand the infrastructure is also important in terms of what happens in our cyberspace. 2024, we had a data breach in our national ID organization. And what essentially happened is that the ID information of millions of people were stolen and it was now publicly available. That included our national ID numbers, addresses, entire family trees, relationships, and maybe more. And same kind of thing has even happened in case of, in the uh, uh, tax regulatory department where a lot of the data was breached due to cyber security issues and was made public. So we need to understand that when we say that we need to safeguard our infrastructure, that does not only pertain to the hard physical assets, but also to the cyberspace. Now, in 2021, there was, if you recall, I'm sure a lot of us can recall, there was a blackout that happened in 2021. What essentially happened, I will say not like a total, I'm not an expert, but from what I studied, what happened is that there was a trip, the Gudu Godu power plant tripped due to something, and that trip caused the entire pretty much like a blackout of 70 to 80% of our country. Now that is something that tells a lot about our the resilience of our infrastructure. And the talk should not be around blaming a personality or blaming someone. The talk should be, I believe, should be principled. We need to understand the inefficiencies, and we need to have a system that does not collapse because something small or something happened locally. So that is what resilience is. The resilience is that you have your alternate paths. Your system is able to withstand shocks, withstand changes, and is able to get back in line if something happens within few seconds or few hours. Another incident that we had, for example, now I'm here basically sharing different kind of examples to basically open the discussion of how important resilience is. In 2021, we had a Goat Key train crash. And if you recall, what happened is that there was a train that was headed in a way in a certain direction, and it derailed from the track due to a reason. Then a train that was coming from the other direction hit the train that had derailed, and due to this, there were a lot of casualties. And when they studied like why this incident happened, what they found out that if you know they are the track is laid out in pieces, and one of the welding joint between those track was not examined or was not checked, that it was done correctly, it was maintained properly, and just because of that tiny thing that the welding joint was not able to perform in a certain way, we had a loss of several lives. So again, I would say this is about the management systems, I would say. The sixth example that I would give is the 2012 Baldia factory fire. And if you recall this horrific incident that happened in Karachi, where this was a garment factory, and a lot of the workers, pretty much, I believe most of them lost their lives. And there was a finding report, and there were discussions on why that happened and what were the reasons behind it. I would not go into those political reasons or whatever there was, but I do know that we need to have a proper fire safety mechanism. For example, if I was looking into the papers and I found the New York Times, just overseas, reported that when this Baldia factory fire incident started, they report that the fire team was able to reach to the site after 1 hour, or they precisely say after 75 minutes. So just imagine there's a fire inside a garment factory, and the fire team reaching that facility after more than 1 hour. So that kind of like kills the entire purpose of the fire safety. And last not the least, we had 2005 earthquakes, and we lost approximately 80,000 lives, 80,000 lives because of that earthquake. Again, a case study of not just poor construction methods, but a lack of understanding of what a resilient infrastructure or development is. So these are just like few of the examples, and my purpose is that we need to look into our infrastructure development methods, regulatory frameworks, and financing models so that we are able to deliver the right value for our people. Now, concluding whatever we talked about the development frameworks, what basically a good development model should have, that it is a strategic initiatives that a state needs to do in order to build safe communities with good connectivity and ensure productivity. Now, productivity and value for money, I believe, should be one of the biggest goals of infrastructure development. If a country is looking into infrastructure development projects, it should not be a development just for the sake of building something. It should be a clear map that what this infrastructure project would mean, how much value this will bring in for our communities, and how we can get the maximum value out of our projects, and we create an environment where productivity is valued. Now, pretty much coming towards the end of our talk, I would like to say that we as a civil engineers and structural engineers have a huge role in infrastructure development. We the civil engineering basically stands as like the backbone of the entire concept of infrastructure development. There could be no one better that who understand the technicalities of infrastructure development better than civil engineers. So we should be at the forefront to forefront. We should be at the forefront of our infrastructure development projects. The second is that the civil engineer is at a position where he can bridge different disciplines, because since the civil engineering understands the core essence of infrastructure development, they are in a much better position to bridge all the disciplines and the stakeholders on a certain project. And third, not but the least, is the policy and the strategy. I believe that from inside the engineering our group, there should be people who go into the infrastructure policy, investment, and development frameworks, because those folks would be in a much better position to understand the technicalities and guide the policy frameworks to ensure that we actually get the best value out of our development models. Now, we talked about the development models and the role of civil engineering. And I just want to close, being a structural engineer, I want to close my talk with few slides on how resilience plays into the hardcore structural engineering. Now, maybe if you open a code book, IBC or any building code or ASC7 for the loads, or you open the material codes ACI, you might not find a chapter on resilience, but that does not mean resilience was not taken into account by the code makers. It is already implicitly embedded inside the building codes. Because, for example, we do a code-based design or a performance-based design, we already take into account all the hazards. Now, what hazard means, we take into account all the loads for the dead load, live load, wind, seismic, snow, rain. So we know what kind of loads we have, and then we design our structure per the code, anticipating that in a belief to which has been, of course, reinforced through repeated experiences, that that structure would behave in a certain way, the desired way. So resilience, although is not a separate chapter inside the codes, it is inherently built into the codes. The code is actually guiding you into a resilience-based design. We, of course, there is a debate how well the code are addressing the resilience-based design. There's a lot of talk in it, but we need to understand that in the essence, the codes are based on that principle. And then what forensic insights basically means, forensics basically means is forensics is a study of the failures. So we have, for example, there was some kind of a structural failure due to some reasons. What forensics would do, they would study that failure, and the insights that would come out of those the study would feed back into the design. So you next time when someone is designing, when they have the insights of why something failed, why something did not deliver its true value, why something was not able to behave the way it was intended to be, those insights that come from the field are invaluable to improve the resilience in the design process. Now, the output of a design and the insights that come is a resilience-based design. Essentially, this is like the very easier way of just drawing everything, is that resilience is an output of you design per certain standards, and you have an understanding of why something may fail or something has failed in the past, and you incorporate and ensure that those failures don't happen and the product is a resilience-based design, but from the structural perspective, of course. Now, narrowing down more even into the how resilience is addressed in structural engineering is if we look into IBC, like I said, we design for specific hazards. Whenever we design a structure, we already we need to account for all the possible hazards that can happen to a building, infrastructure, or any kind of structure. So that is one part. Then we have risk categories, and anyone who's familiar with risk categories, I'm sure most of us are. But what risk category means is there is like a table in IBC which says that depending upon the usage or the structure type, you have to increase your forces by a certain amount. So essentially, what the code is doing is that if you have a facility that's very important and needs to stay operational after an earthquake, for example, a hospital or a schools, because schools are used as a shelter after the earthquakes, or you have a very important facility that's going to be used by hundreds or thousands of people and it's very important to stay operational, you need to bump up your forces by a certain factor. That factor could be 25%, that factor could be a 50% bump, depending on your structure type. So what that essentially does is you have your more resilient what it's trying to do is it's basically trying to make a more resilient design. Now, the fourth aspect is the performance-based design. The codes essentially cover all the code-based design, and then they let you go into the performance-based design as an alternate method. And I think I don't have the time right now to go into the details of the performance-based, but performance-based design can essentially design for different levels of hazards to ensure that the structure can deliver at all those hazard levels as intended. Now, if I look into the material codes, for example, ACI, if we look into the ACI, we know ACI has different chapters. For example, chapter number 18 covers the earthquake resistant something structures, if I don't forget it. So what that basically means that if your structure is in a certain seismic prone region, you design for a better performance. You ensure that the detailing of the concrete, the reinforcement detailing, can ensure a certain level of ductility, that your structure is able to perform in a better way where your hazard is higher. So that again is essentially a resilience-based concept. The other concept that you will see again, in the same material codes, for example, ACI, they address durability and fire resistance. Again, the hazard is not just the seismic, the hazard could be the environment itself. Now, if you want to build a more durable structure, that means it is resilient. It is resilient to the environment. And we not go into the detail how we control that durability through concrete cover or certain protective coats that we can increase the durability of the structure. And the last is the fire resistance. And what fire resistance again means is that in the ACI would tell that if ACI and IBC and other references will tell you that if you need your building to withstand, for example, 2 hours of it says like a 2 hours of fire that it should be able to withstand and not collapse. It will tell you you need to do this and this in your design. You need to have this much concrete cover. You need to have this, and the different kind of concrete classes for the exposure to ensure that you have the resistance against the fire. So all these, if you look into the codes, what I'm basically trying to say here, the codes already address the basic needs of a resilience-based design. They might not cover the entire spectrum of it, but they definitely do cover the basics. And the codes are actually based upon giving you a resilient-based design. Now, one of the last slides I have here talks about the key factors that could compromise your structural resilience. Your structural resilience could be compromised because the design was faulty. Our assumptions that we assumed something in our design that was not correct to start with, that can jeopardize our entire structural design. Another failure that I've seen repeatedly is of the connections. I've seen repeated. So in our structural design, we are more at times we are more focused on our member design, but we need to understand that the connection design is equally or even more important in the member design itself. So this is like another case where your resilience could be compromised. And the third case, I think, actually, which I believe I should have covered in the start, is the lack of redundancy. What redundancy means is that basically, uh, I'm sure the if we have structural engineers here on the call, they would understand what redundancy means. But in simple words, what redundancy means is that you do not rely on a single element or a single load path uh, for your entire performance. You have multiple load paths so that if capacity is exhausted in a certain direction or by a certain element, there are other elements in the structure that can support that frame and avoid a total collapse can avoid a total collapse. So this is again a concept of resilience, and if compromise can lead to a disaster. And last three are pertaining to poor construction practices. Of course, if we have the best design in the world, but if the construction practices are not good, then that design would be just thrown out of the window, and what we get is a structure that's not resilient. And the last two are pertaining to the events from the environment or human events that maybe we did not foresee, and there were some extraordinary events or environmental degradation that caused the resilience to be compromised. So these are like this with this I pretty much close my main structural aspects of resilience. And summarizing my talk, I think when we talk about sustainable resilient infrastructure, first we need to actually be discussing the development frameworks, the development models, the development policy, the vision for the development. That needs to be the base of the entire thing. Then on top of it, we what we need is a good management system. A management system that understands that an infrastructure is an asset class. An infrastructure is not something that just serves the basic needs, but it can go way beyond. And we should need to have the management system that can ensure that our infrastructure is able to deliver its value over a period of decades. And when we have these right development frameworks and management system, the output would be a sustainable and resilient infrastructure. So with this, I close my talk uh, in hopes that I have been able to raise important questions around the development models, the financing models, and the engineering perspectives of how we should be looking into infrastructure development. Thank you.
Okay, thank you, Rehan. We have a couple of questions. Let's go through the questions first, and then I will make my concluding remarks. The first one is from Mir Muhammad. He is asking, what are the possible ways to bridge the gap between policymakers and the engineers regarding today's topic in context of Pakistan?
Yes, I think this is like the most important crux of the entire crux of the presentation. And very unfortunately, we all know what the answer is, but it's sometimes difficult to respond or to develop those right bridges between the policymakers and the engineers. But what just giving from the principle a principal answer on this, I think what needs to happen, we should be an open society. What an open society basically means that we should have environment where the feedback can come in very easily. So, right, if we have the if the policymakers understand that whatever they are developing in terms of the vision they have in terms of development could be much better if they are open to the input from the engineers or the technical community. And the technical community also, I guess, needs to understand the frame from the mindset or the frames from where the policymakers think. And it may be slightly that we have to understand all the sense, not only understand all the sensitivities, but also play in a way that our voices are heard and the and the policymakers understand that the development projects would be able to deliver its right value over the period of time if the engineering inputs and the technical inputs are valued like they should be. I think that is what I have to say on this. So I think the mic is muted or something.
Oh,
So
I'm so sorry. This question is from Parvez Noshahi Sahab
जी.
from Saudi Arabia. He's asking, in the background of recent floods in Punjab created mainly due to huge amount of water released by India in very short period of time. Therefore, IWT is not sustainable. IWT's Indus Water Treaty is not sustainable for Pakistan's perspective. Being expert of subject, your assessment of this non-resilient treaty. Would you like to answer this question?
Okay, so first I would say with humbleness, I'm not an expert of water management or that treaty, but I do understand that we cannot solve our problems by blaming others. And I strongly believe this thing from the very core of my heads. We cannot solve our problems if we keep blaming our neighbors or keep blaming certain elements within our own society. We need to understand that we have a very big management issues, and these floods were happening even before 2025 when this treaty was still in place, when the treaty was already there, and these floods were already there. This is not the first time a flood has translated from a hazard into a disaster. This is not the first time, and we know unfortunately this might not even be the last time. So I believe instead of looking outside our borders or towards certain sections of our society, it's much better if we look within ourselves and craft out the right management systems to address such challenges.
Hmm. I would also like to add on it. You see, the floods that came in Pakistan in 1973 or 1974, some people report that that flood was much bigger than the one we are experiencing now. But that flood did not wreak such a havoc what this flood has wreaked. So definitely the mismanagement is there. Quite a big mismanagement is there. So I 100% agree with you. Now we have another question from Parvez Shai Saab. He's asking, do you consider piles as a structural member of the facility? If so, as expert, your comments on resilient piles for the different types of subsurface conditions.
Yeah, if I'm trying to understand because this question is I guess trying to cover a lot of different topics, but
That what I also
yeah,
think. If you want
yeah,
to answer it,
yeah.
okay, otherwise we can skip this question.
Okay, sure. I'll go with that.
Okay, okay, no issue. Now we have a question from Ijaz Ali, and he is asking if an area has previously experienced earthquakes with the magnitudes up to 7, but a stronger earthquake magnitude of 8 or high occurs for the first time and causes significant infrastructure damage. can we conclude that the infrastructure is not resilient?
Um, okay, so that's an interesting question. So first, the 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 calculations for all the hazards are probability based. There is no deterministic approach. I cannot I don't know. No, engineers cannot calculate the maximum possible earthquake with 100% assurance. There is always an element of probability when we calculate the maximum level of water or earthquake or any hazard level. Now, that does not mean that if I cannot calculate something with 100% of certainty that I cannot deliver the desired goal. That's why ductility that is introduced in structural engineering and redundancy, which is alternate load paths. The concept is that if we know the structure is going to behave in a certain way for a certain load level, if the loads exceed by 20%, 25%, 30%, the structure should still be able to generate enough warnings so that we can avoid a total collapse, or we can at least give enough time for the people to evacuate that building or that infrastructure before that collapse. For example, considering there's a 9.0 earthquake, still the building needs to behave in a certain way so that we can save enough lives. So, I mean, that's what I have to say on this subject.
Now we have probably the last question. Let me check. Yeah, the last question. And this is again a bit tricky one. So, is urbanization leading to difficulties in maintaining a resilient infrastructure?
I mean, I'm sure. It's sure the migration from small cities to big cities is going to create new problems. It's going to create new issues, but it's not something that can be stopped altogether. But I do believe it can be handled in a better way if those smaller cities or towns are also given equal or better opportunities to stop that migration from happening to a certain city centers. But so yes, there is going to be stress on the main cities to cater to those population and still deliver resilient infrastructure, but that can be handled at the engineering level and at the policy level, both.
Okay, thank you for your answers. So Q and A stands closed now. And I was just looking for a comment. Yeah, this is the Miss Nosheen Zaib has just made a comment. Is it possible for PSCE to share this lecture in PPT form? Well, Miss Zaib, it is like this, that all our lectures are recorded and they are uploaded on our YouTube channel. You can, I think, download from there free of charge, and are also on our website. On YouTube channel, the lecture will be uploaded right after we close this session. But on the website, it takes 2 to 3 days to upload the lecture. So, but if you want the PPT, that is the lecture in the PowerPoint format, uh, uh, that you have to contact our coordinator, Mrs. Sadia Naveed. You can call her or you can contact her on our email, and then she will contact the speaker. And if he allows the PPT, because we don't have the copy of the PPT in the PPT format, if he gives that format to her and allows, then inshallah, she will be very happy to hand over the lecture in PPT format to you. So this was the announcement. So now I was thinking how to uh, close this lecture and how to thank the speaker on this lecture. Because you see, ladies and gentlemen, today's topic uh, did not delve into technical calculations or but yet it remained firmly rooted in the domain of civil engineering. And this was a very, I think the subject was quite difficult, and it posed a unique challenge in terms of presentation because it required both conceptual clarity and contextual relevance. So, in my view, engineer Rehan Bai, such a young engineer, navigated this complexity with commendable skill. I really congratulate him. His
Thank you, sir.
presentation was articulate, well structured, and accessible, effectively bridging the gap between technical depth and what should I say, and broader engineering implications. So, uh, Rehan, thank you very much for such a
Thank you, sir.
uh, knowledgeable lecture. I
Yes.
really congratulate
Yes.
you. I'm so happy that at such a young
No.
age you can present such a informative lecture with so much clarity.
Yeah. Thank you, sir. And it's a pleasure for me to be back at this platform. And I hope I was able to bring up
No, you did
the
it very
important
well.
questions.
You
Yeah.
did it very
Yeah.
well.
Yeah.
I think everybody in the participant will agree that you did it very well. And now let me go to my agenda. Sometimes it becomes very difficult to speak extempore if you have to thank someone. So now it is like this that today's lecture has come to an end. Next lecture is on 18th October 2025, same time, 2 p.m. Pakistan Standard Time. And our speaker is Dr. Muhammad Irfan, and the topic is load testing of reinforced concrete piles. I repeat, the next lecture is on 18th October 2025. Topic is load testing reinforced concrete piles, and speaker is Engineer Dr. Mohammed Irfan. You will get your certificates, all the participants who registered for this lecture from onwards 18 September, which is Thursday, from our office, which is located at 14A1 Block B, Model Town Extension, Lahore. And before coming, if you want to confirm regarding the readiness of your certificate, you can contact Ahmed Akram. His telephone number is 0347 462 5111. So, ladies and gentlemen, now we have concluded today's program. My thanks to my coordinating person and my IT person. Without both of them, this telecast on Zoom and Facebook would not have been possible. Inshallah, now I will see you all. Thank you very much.
Thank you. Bye.
Before Rehan, your shield and your certificate will be delivered at your home address, inshallah.